And welcome back to my channel, the new video. In this video, we're continuing the data structure algorithms bootcamp, and we're doing another nice question of binary trees. In this, the question says, convert a binary tree into a doubly linked list. So if you don't know what a doubly linked list is, I would encourage watch my linked list introduction playlist. It's very simple. We will have a head and a tail, and you have, we have linked list like this. Head, tail, and it will also be pointing to the previous node. So every node is pointing to the node in front of it and also behind it. Okay, so that's what a doubly linked list is. And we are given head and tail, and well, we are not given head and tail, we have to create it, for example, but we are given a binary tree. So we are given a tree like this. Okay, this is 5, 6, this is, let's say, 3, this is, let's say, 1, this is, let's say, 2, no 2, 4, this is, let's say, 2, okay, this is 1. So you have to convert this tree into a doubly linked list. How are we going to do this? Let's say it is a binary search tree, so you have to convert it into a doubly linked list that is sorted. So obviously we are going to use traversals, but the question is, which kind of traversal will you be using? What is the traversal that gives us the sorted order in a binary search tree? In order traversal. So you start from here. Will I take this? No, I will go in the left. I will go in the left. I will go in the left, null. So I will then print the current node, which is 1. Then I will go right, nothing. Then I will go here, print the current node. Then right. Then I will go back. Left is printed. Now I will print the current node 3. Then right. Okay. Then the left is printed. I will print the current node, which is 5. And then right. In order traversal. We all know what in order traversal is. Just watch the linked list tutorial video if you haven't already, and if you're having doubts in this, but this is basically how it will work. Now the question is very simple. We will do in order traversal, but while we are printing it, we will build our doubly linked list. So when I printed this 1, I will check, is head equal to null? Yes, currently head is equal to null because the list is empty. So I will assign this as head. Then I will traverse again. Now I have 2. So I will be like, is head equal to null? No. So I will be like, the current pointer that I have, let's say tail is also equal to this. I will say tail dot next is equal to this, and this currently previous is equal to the original tail that I had. And then tail will be updated to the new one. Then I will print 3. I will like, okay, tail dot next is equal to the current node. This current node dot previous is equal to the previous tail. Okay, very easy stuff. Until then, we will move forward. Pause this video, try it yourself, and then look at the code solution. Okay, so I'm gonna go to my folder. By the way, you can check out the link to the code in the description below. I'm gonna create a new Java file, or I'm just gonna go to the advanced tree questions one and create a new file, double linked list.java. Zoom in a little bit. Double linked list. Cool. So that's what we have here. What is the double linked list going to have? It is going to have, as you can see over here, head, each node. If we talk about the node, what is the node going to have? So let's say I create a new node over here. Let's say we have a new node. I'm going to call it just class node. This is going to have a value, node previous, node next. Okay. Public node constructor is going to pass value, this dot value is equal to value. Okay, this is my node. I'm going to call this one actually linked list node. Then I'm going to create, let's say we create a tree node also. Trees have what? Left and right. Int val. Always make sure when you copy paste, tree node left, tree node right. Public tree node, int val, constructor, done. Cool. Sounds good. Now the doubly linked list that we have over here, I'm going to create what? Head and tail. So I'm going to say two types. So tree node head and tree node tail. Sounds good. After this, I'm going to have, what am I going to have? Converting, how do I create it? I have to convert it from a binary tree. It says binary search tree is given. Convert into a doubly linked. Okay. Public, it will return tree node, convert what? Tree node root. By the way, this will not be tree node, this will be linked list node. Not a tree head and tail. Tree is left and right. Linked list head, linked list tail. Here on the screen you can see it is saying convert tree node root. Sounds good. Now some basic checks. If root is equal to null, return null. Otherwise I'm going to call my helper function, pass my root node in it. Okay. Then I'm going to say return head. Sounds good. Don't have to make it public. I can say private void helper. Helper takes in a tree node. Not a problem. Okay. I can say if node is equal to null, return null, otherwise in-ordered reversal. So what I'm going to do is I'm going to call the left first, node.left I will call first, then I will call the current, and then in the end node.right. Okay. So when I talk about the current, let's say you have found the answer, let's say this is the one. So what do we do? We create the new node. So linked list node new node is equal to new linked list node, and the value will be what? Node dot value. Now if head is equal to null, head is equal to new node, tail is also equal to new node, only one element. Okay. Otherwise tail dot next is equal to new node, and then tail itself is equal to that new node what we just saw. But before that, so tail dot next is equal to new node dot previous is equal to tail also is left. New node dot previous is equal to tail is also left, and tail is equal to new node, and then helper node dot right. That's it, done. Pretty simple stuff. Cool. This code that you can see, I will leave the link in the description as well. So you can check it out. Alright, so that was it. Pretty short question, but very simple. May have looked intimidating, but it was not. The key, how did I know what to do, is the hint I was like, you have to do ascending order. That's why we did in-order traversal, and we did exactly what in-order traversal says. Do the left first, then do the current node, whichever one you're at, then do the right. Simple stuff. If this was unclear, you can check out the previous videos, and I'll leave the links in the description below. Thanks a lot for watching. See you next time.